Everyone, and welcome to lesson 1.2. Today we are going to talk about the definition of perpendicular and perpendicular bisectors. Today we are going to talk about what that term perpendicular means. First and foremost, it means that we have either lines, segments, or rays that intersect to form right angles. Now, segments and rays can be perpendicular to other lines or other segments and rays. The box in the figure indicates that the lines are perpendicular. Notice the symbol for perpendicular is this figure right here. It almost looks like you're creating two small right angles. Okay, and again, you're going to see perpendicular lines represented a variety of ways. You have either two lines intersecting to form that 90-degree angle. In fact, they actually unofficially form four right angles. We usually just mark one though, but there are officially four. You see this box here again that indicates that these are perpendicular. This is two segments that are perpendicular. This next one we have a ray and a segment that are perpendicular, or even officially we could say that AC and AB are perpendicular, creating that right angle and that triangle. Okay. Now, a perpendicular bisector not only creates that right angle, again, it's perpendicular to a segment, but the important piece here, it also is going to divide it into two congruent segments. So you're perpendicular and you're bisecting. So in this example that's given here, AC is the perpendicular bisector of segment DB. Now, a reminder, we can only bisect segments, and just because something is a perpendicular bisector, it doesn't mean it is necessarily getting bisected as well. So when we said that AC is the perpendicular bisector of segment DB, does that mean that DB is also bisecting AC? The answer is no, right? We must also know that DB is a perpendicular bisector. That also has to be said. We can't just assume just because one of them is a perpendicular bisector that the other is going to do the same thing. So in this case, for our example here, only DB is getting cut in half by AC. They are, however, creating four 90-degree angles. Now, what is the difference between a line that is a perpendicular bisector to a segment and the perpendicular bisector of a segment? Well, one is doing the cutting, okay? So the perpendicular bisector, perpendicular segment is, or line is creating right angles only. A perpendicular bisector also cuts the segment. Okay, so again, there is a difference between just being perpendicular and then also being a bisector to a segment as well. Now, looking at some examples, they're telling us in this first example that that line AB is the perpendicular bisector. So here's the line they're talking about, AB. It is the perpendicular bisector of segment CD. So what that means is segment CD is getting cut in half, and E is the midpoint of that segment, right? So we're going to mark our two congruent segments. Now, going back to what we talked about previously then, C to E and D to E must be equal to each other if we know that this point E is a midpoint, and we're allowed to assume that from that given information of perpendicular bisector. So if we set up and solve, we end up with 3x being smaller than 7x's. So we have a total of 4x's. Add the 5 to both sides. And we end up with, when we finish here, some division by 4, to get a final answer of x equals 3. Now, letter C wants us to find x if angle AED is 6x minus 12. Well, let's look at angle AED. Well, again, given this information here, that we have a perpendicular bisector, we know this angle is going to equal 90 degrees. So that angle our AED has to be 6x minus 12, and we know it will equal the 90. So add 12 and divide by 6. X ends up being 17 this time. On the next page, try the next one on your own. Part A is asking you, after knowing that RY is the perpendicular bisector of UB, if UM is 12, how much is MB? What's the total length of U to B? And then what would the measure of angle RMU have to be? All right, in our next set of examples, we are finding the values of X and Y given that line NQ is perpendicular to line PR. Again, unofficially, they don't often mark it. They only marked one picture, but when we know these are perpendicular, we are creating 4 right angles. So for instance, to solve for X, 4X and 2X are representing POM and NOM. Well, those two angles together are complementary. They are creating a 90-degree angle. So as we set up and solve, condense down, 2x plus 4x, we have 6x's. And as we divide over, we divide 90 by 6, we end up getting x to equal 15. Try solving for this value of y, given that this angle QOR is 5y plus 20. Last but not least, reminder, they are giving us VZ. This line is the perpendicular bisector of segment XY. Again, of XY. That's the one getting cut into 2 equal pieces. So we know point W is the midpoint of that segment XY. So after labeling our given information that XW is 6x minus 7, WY is 3x plus 8, find x first, then plug it back in to find the length of x to y. Thanks everyone for watching. We will work more in class.